For a better overview, the life cycle of a plant is divided into 4 phases. The emphasis for the application of S7 graph is the implementation phase. However, the characteristic properties of S7 graph can also be perfectly used in the testing and commissioning phase, as well as in the later operating and maintenance phase. The SIMATIC software offers you the selection of several programming languages. The basic package contains the languages Ladder, FBD, and STL. The often used programming languages S7SCL and S7 Graph are optional or available with Step 7 Professional. While programming with STL is hardware intimate, Ladder, FBD, and S7 Graph enable you to connect graphic elements with each other. S7SCL is a programming language which, regarding syntax, follows the easier, manageable, high-level language Pascal. This selection of different languages enables you to use the most suitable one for the task, so their respective special features can be used to the best advantage. Basically, all automation tasks can be solved with the basic languages Ladder, FBD, and STL. Tasks such as data management algorithms can be solved particularly fast and clearly using the language elements provided in S7SCL. In case of sequences, which can be divided into individual processing steps, the automation solution is considerably simplified using sequence chains in S7 Graph. All languages comply with the IEC 61131-3 standard. S7 Graph is discussed in the following and its application demonstrated by means of a specific automation task. Let us first take a look at the advantages of using the engineering tool S7 Graph. Apart from clarity, which results from graphical programming, S7 Graph can be easily learnt due to its intuitive programming and operation. S7 Graph is characterized by its low implementation times, as the code generation is less prone to errors. Also, users without special PLC knowledge, such as technological specialists planning and developing a plant, can implement their knowledge of technological process structures directly in a runnable PLC program using S7 Graph. S7 Graph achieves optimized program runtimes as only the active part of the program is being processed. The graphic programming interface reduces the search times for certain program sequences, hence reduces testing and commissioning costs. Nevertheless, there is still enough space for additionally increasing comprehensibility by means of code commenting. S7 Graph also provides a good basis for visualizing technical processes on an HMI system. This, together with the integrated process diagnostics functions, results in increased performance and reliability of your machine or plant. A number of applications within production and process technology show sequential structures. These sequence chains consist of individual steps that are processed successively, whereas sequential processing can be extended by branches. The following structures occur most frequently. During the linear sequence, the individual steps are processed successively. One step may contain different actions. The transition from one step to the next occurs via conditions that must be true. In the alternative branch, also depending on a condition, only one of several possible sequence branches is processed. The simultaneous branch enables almost simultaneous processing of different sequence branches, so that in this case, several steps can be processed as it were in parallel. The programming effort for realizing such technological tasks with sequential control is considerably less than with logic control. These advantages are provided to you by the engineering tool S7 Graph, as it depicts these technological sequence structures directly. In the following, we will look at a specific example in which we illustrate how the technological task of a drilling process is realized in an S7 graph program. Our example has the following functionality. After pressing the button for starting the process, the cylinder slides the workpiece from the magazine to the drilling machine. The drill now drills a hole in the workpiece. During the drilling process, compressed air for chip removal is applied until the drill is back in the starting position. Then the slider moves back and the finished workpiece is ejected. If no more workpieces are left in the magazine, the indicator lights will indicate this, and the process be interrupted. The technological sequence structure results from the task described in this example. We now want to show you how simply the technological sequence structure can be realized as a PLC program using S7 Graph. We introduce the necessary activities from calling the editor to testing the complete sequence chain.